This video is over section 3.6, solving quadratic equations by using the quadratic formula. There's going to be a separate video on how we get this formula, but the quadratic formula states that for a quadratic equation of the form ax squared plus bx plus c equals 0, where a is not equal to 0, the solutions are x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is something you're going to need to take to memory. So we're going to apply this formula. And note that here we need to have a 0 on the right side and no parentheses or anything on the left side. So let's get started. We've got 30x squared plus 13x equals 3. So we need to get a 0 on the right side before we start. So we're going to have 30x squared plus 13x minus 3 equals 0. And now we have our a is 30, our b is 13, and our c is negative 3. So the formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And I like to do this inside part first. It's called the discriminant, just so my work doesn't get too sloppy. So I'm going to do that off to the side. B squared minus 4ac. For us, it's going to be 13 squared minus 4 times 30 times negative 3. Let me make that a little bit smaller, or just shift it over, I guess. There we go. And so when I do that, I get 13 squared is 169. And then I have 4 times 30 times 3, and that's going to be plus 360. And that gives me 529. Oops. All right, so I'm going to take that back into the formula. So we have, x equals negative 13 plus or minus the square root of 529 all over 2a, so that would be 60. So if I do the square root of 529, let's see. That would be 23. So this is going to be x equals negative 13 plus or minus 23 over 60. It's not really wrong to leave it this way, but I don't think that the online platform will take this as an answer. So we have two solutions. We've got x equals negative 13 plus 23 all over 60. And we've got x equals negative 13 minus 23 all over 60. So for the top one, that gives us, what would that be? 23 minus 13, that would be 10 over 60, or reduced would be 1/6. And for the bottom one, that would give us negative 36 over 60. And reduced, that would be negative, 6/10, which would be negative 3/5. So let me move that over so we have room for the next problem. Awesome, so our solution set would be negative 3/5 and 1/6. Okay, great. So now we're going to do the next problem. Before we start, we need to get rid of our parentheses and get a 0 on the right side. So we've got x squared minus 5x, and then I'm going to go ahead and move that 21 to the other side and do minus 21. So here we've got our a is 1, our b is negative 5, and our c is 21. So our formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So like I did it before, I'm going to take this b squared minus 4ac, the discriminant, off to the side, just to keep my work a little bit neater. And so that's going to be negative 5 squared minus 4 times 1 times negative 21. So that's going to be 25 plus, 4 times 21 is 84. And so that is 109. I don't think that will simplify. Let's see. no, it's prime, so 109 is prime. So here when we plug in, we're going to have positive 5 plus or minus the square root of 109 all over 2. And since the square root of 109 does not simplify, this is just our solution set. All right, for the last one, we have a word problem. It says a fireworks mortar? I don't know what that word is launched straight up from a pool deck of 4 meters off the ground with initial velocity of 60 meters per second. Write a model to express the height of the mortar in meters above the ground. So the formula we're going to be using is S equals negative 1/2 gt squared plus v naught t plus S naught, and that's in your book. But just so you know, G is gravity, V naught is initial velocity, and S naught is initial position or, I'm just going to position, or height. Okay, great. So because this is a meters problem, our gravity is going to be 9.8. So when we plug that in, we're going to have negative 1/2 times 9.8. So that would be 9.8 divided by 2. That would be negative 4.9 t squared plus the initial velocity is 60 t plus 4. And just for your notes, gravity in meters is 9.8 meters per second squared, and then gravity in feet is 32 feet per second squared, just for your notes. All right, for the next question, it says find the times at which the mortar is at a height of 60 meters, round to 1 decimal place. So we're going to take 60 equals negative 4.9 t squared plus 60t plus 4. So I need to subtract 60 to get a 0 on the left side. So we've got negative 4.9 t squared plus 60t minus 56. And then now we can use our quadratic formula. This box is kind of tight, so I'm going to have to, we'll just have to see. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I'm just going to do b squared minus 4ac down here. So that's going to be 60 squared minus 4 times negative 4.9 times negative 56. And I'm going to have to use my calculator on that. So let me move that to the side. So we're going to do... This is going to be 3600 minus 1097.6, and so that gives us 2502.4. So I'm going to make that small. Oops. Just to get it out of the way. Oh no. Okay, hold on. Okay, so we're going to take this and substitute it right here. All right, so that gives us negative 60 plus or minus the square root of 2502.4 all over 2a, so it would be negative 9.8. And when we simplify that, I'm going to jump over here for space. We take the square root, let's see, of 2502.4, and we're going to have negative 60 plus or minus this 50 point, we'll just say 02, all over negative 9.8. And again, this makes two solutions, one with the plus, one with the minus. So we know that the one that's going to be positive is when they're Actually, they might both be positive. Okay, hold on. So I just need a lot more space. Let me jump down here. Sorry. So we are going to have negative 60 plus 50.02 over negative 9.8 for t, or we're going to have t equals negative 60 minus 50.2 all over negative 9.8. So let's do those off to the side. So let's see if I have, this one would be t equals 1 point, how many decimals did it say? 1 decimal, t point 1.0 seconds. And for this one, I'm going to get let's just be 0 too. 11.2 seconds. So to answer the question, it says find the times at which the mortar is at a height of 60, round to 1 decimal place, at 1 second and at 11.2 seconds. This will be at a height of 60. A very similar problem for part C, same thing but at a height of 100. So we're going to have 100 here instead. Negative 4.9 t squared plus 60t plus 4. When we rearrange, we're going to have 0 equals negative 4.9 t squared plus 60t plus 96, or sorry, minus 96. Okay, we're going to do the same thing. B squared minus 4ac is 60 squared minus 4 times negative 4.9 times negative 96. Let me get my calculator. So it's going to be 3600 minus 1881.6. So that gives us 1718.4. So I'm going to make that small. But now we can use our formula. So we've got t equals negative b plus or minus the square root of, I'm just going to go ahead and plug it in, 1718.4 all over 2a. And when we plug in b and a, we're going to have negative 60 plus or minus the square root 1718.4 all over negative 9.8. And so that'll be negative 60 plus or minus, let me do that real quick in my calculator. And we get 41 point, we'll do 2 decimals, 45 all over negative 9.8. And just like here, we're going to split it into 2. So we've got t equals negative 60 plus 41.45 over negative 9.8, or we've got t equals negative 60 minus 41.45 all over negative 9.8. Okay, so for our first solution, we're going to have 1.9 seconds. And for our second solution, we're going to have 6.12 seconds. So at those 2 times, the rocket is 100 feet, or meters.